Hi everyone, this is our video lesson for Chapter 8, the very first lesson. The first lesson is in 3 different parts, Day 1, Day 2, Day 3. So this is Multiplying Monomials, Day 1 for 8-1. Let's define first what a monomial is. A monomial is a number, a variable, or a product of a number and one or more variables. So a number such as like 7, right? Or a variable such as like x. Or a product is the answer when you multiply. So 7x is the product of a number and a variable, so 7x is also a monomial. X times y is xy, that is also a monomial. However, x plus y, now that's a sum of 2 different variables. This one is not a monomial. Okay? Monomial, M-O-N, that means 1. And then nomial right here, that means number. So one number. So when we multiply 2 numbers together, that's still, 2 times 3, that's still one number of 6. So that's why it could be a product. Okay, but it's not a sum, it's not a difference, it's a number, a variable, or a product. Let's do some practice then. A number like -5, this is a monomial. A variable such as the letter x, that is a monomial. However, the sum of 2 different variables, this p plus q is a sum, that one is not a monomial. In fact, we call that a binomial. We'll get to that a little bit later. This c divided by d, this is what a quotient would be. Quotient is the answer that you get when you divide. So c divided by d, this one is not a monomial. So that makes people think that this one here is also not a monomial. However, if you divide by 5, that's the same thing as multiplying by a 5th. So it's kind of like saying 1/5 times a times 1/5 of b times 1/5 of c to the 8th. This is one term. As ugly as it may be, there's no adding signs in between, there's no subtracting signs in between. It's 1/5 times all of those, so it's still one number. This one is a monomial. Okay? All right. One thing we need to first recognize is anything raised to the 0 power is the number 1. If you raise anything to the 0 power, it is 1. Let me prove that to you in our graphing calculator here. If I raise 8 to the 0 power, what number do I get? Ha! I get a 1. What if I take 25 and raise that to the 0 power? It's just the number 1. What if I take 1,753,946? What if I raise that to the 0 power? There's no way a number like that can be a 1, is it? Would you look at that? It is. Anything raised to the 0 power is just the number 1. I will explain that to you in a couple days when we get to a quotient property. For now, just trust me on this. Anything raised to the 0 power is 1. So a variable raised to the 0 power is still just the number 1. And a mess like 3x to the 5th, y to the 7th, if all of that is in parentheses and it's raised to the 0 power, well, anything raised to the 0 power is the number 1. So 1, 2, and 3, the answer is just 1. All right. Let's take a moment before we do question number 4, and let's bring you back to like 4th grade. Ready to go back to 4th grade? What if I take 2 squared times 2 squared times 2 to the 3rd? Let's just think through that for a second. If you asked a 5th grader to do this, the 5th grader would probably take 2 times 2, 2 squared is 4, and then 2 times 2 times 2, 2 times 2 times 2. This would give 4. 4 times 2 would be 8. So it would be 2 to the second times 2 to the third is the same thing as 4 times 8. And then they would take 4 times 8 and they would get 32. And that is exactly the right answer. In high school math and intermediate algebra, which is where you're at right now, instead of doing this concept, let's take 2 to the second times 2 to the third. As long as the bases are the same, you guys, base 2, then you can add their exponents and get 2 plus 3. 2 plus 3 is 5, so 2 raised to the 5th. What is 2 times 2 times 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32, just like what we see here. So whether you do it this 4th grade way or whether you do it this high school way, you get the exact same answer. So then you're going to ask the question, well, why don't we just always do it the 4th grade way? It's because now we deal with variables. Now we can't just simplify it in the same way that we used to. So instead, we use this rule. When our bases are the same, we're going to add exponents. We're going to add the exponents together. So this is base x. Base x, as long as the bases are the same, you can take 3 plus 5 to get x raised to the 8th power. And that is the correct answer for question number 4. On question number 5, you have base and base that are the same. So you can take x and take 4 plus 5, those are the exponents, and get x to the 9th. The coefficients, the number 3 and negative 6, you do that just like always. You would multiply. So you're going to multiply the coefficients, 3 times a negative 6, to get a negative 18. So a negative 18, x raised to the 9th power. The coefficients you multiply to get negative 18. The common bases, you would add their exponents. 4 plus 5 is x to the 9th. Let's try another one. This one kind of has a coefficient of 1x squared y to the 3rd times 1x to the 4th y to the 2nd. Well, 1 times 1, when you multiply the coefficients, is still just the number 1. So we don't even have to write that. X squared and x to the 4th, you would add exponents with the common bases of x, and you would get x to the 6th. Here is a y base and a y base. You would add exponents when you multiply with common bases. So 3 plus 2 is y raised to the 5th power. X to the 6th, y to the 5th. Question number 7, when we multiply coefficient times coefficient, negative 3 times 4 is a negative 12. With common bases, you would add their exponents. So here's a common base of x, and here's a common base of x. The coefficient is a 1 right there because if no coefficient is written, you assume it's a 1. So x raised to the 1st power and x raised to the 3rd power, you would add those to get x raised to the 4th power. You have a common base of y, so we can add their exponents. 2 plus a negative 1, 2 plus a negative 1 is just 1. So you'd get y raised to the 1st. But once again, you usually don't see this 1 right here. It's understood to be an exponent of 1 if nothing is written there. So there's our answer for question number 7. Question number 8, our last one for today. We're going to take coefficient times coefficient. So a negative times a positive is still going to be negative. You're going to take numerator times numerator, 3 times 4 to get 12. And denominator times denominator, 5 times 7 is 35. So 12 35ths is your fraction, your coefficient. Now our common bases, x's, you have x to the 1st and x to the 5th. With common bases, when you multiply monomials, you add the exponents, so then you get x raised to the 6th power. And the same is true with common bases of y. You add the exponents. 2 plus 1 is y raised to the 3rd power. So this is the correct answer for question number 8. Just so you know, oftentimes we also write everything in the numerator. These variables, x to the 6th and y to the 3rd, also act as numerators. So you could write it as a negative 12 x to the 6th, y to the 3rd, divided by 35. This would also be an appropriate way to write that answer. So either way, I will accept if you're doing this as an assignment or as a test. Make sure that you make any, circle any questions that you have on your paper, or make any notations about any questions that you have so that you could ask me next time you see me. Have a great day, everybody. We'll see you later.